Hi everyone, today we're going to look at system of equations. And what this means is we're going to have more than one line, one equation on our graph. All right, usually it's two. When you get higher up into math, it will be three or four. It could have as many as it wants, but it's called a system of equations. So the first thing we're going to do, let me get a different color. We're going to graph this first equation. It says y equals x plus 2 onto this graph. So when you go to graph, remember we can start with our y-intercept, which is our 2, and we're going to put it right here on our y-axis. Try and get my dot to where you can see it. And then that x, remember it has a 1 in front of it, and that is actually our slope. So we're going to go up 1 and over 1 to the right every time for our slope. And keep going. All right, so we're going to keep making those coordinates up 1 and over 1. That is our slope as we go along. And we can go throughout the whole graph. We do want to go through the entire graph because we don't know. Let's see, that's a horrible line drawn, but it's okay. It's pretty straight. All right, so now let's look at number 2. I'm going to change my color so you can see a little bit of difference. So let's see red. On the same graph, okay, this one over here on the right, we're now going to graph this one. So it starts at the 8, because this is our y-intercept. So I'm going to start up here, 0, 8. And then I'm going to come over here, -1. I have a negative sloping graph, and it's a -1. So I'm going to go down 1 and over 1 every time. It's really hard to show you the dots. Alrighty. So you can continue. Gets all the way to the end of your graph. Draw a line connecting your points as best as you can. Alrighty. So, do the two lines intersect? Well, yes, they do. Where is that coordinate? Which one is it? So if we look over here at our x-axis, we go to the 3, and we can come up to the 5. That is our coordinate, 3, 5. That is our intersecting point. Okay. Is the point 3, 5 a solution to the first equation? So how we can decide that? Remember, this is x, y. We can plug that in. The y is 5. And does it equal 3 plus 2? We would see, does that left side, does it equal, we could even put a little question mark kind of considering it. Does it equal, what's 3 plus 2? 5. So yes, it does. Okay, that's one way we can tell. Alrighty. All right, the second way that you can tell is it is actually a point on that graph. It does actually end up on that line. That's the second way you can kind of tell. So then on number 4, it says the same thing, but with a different equation. So we could plug in 5 over here, and then we'll plug in 3. Remember, though, this time it has a negative out in front, and then plus 2. So all right, so I just messed up. This is not a 2. Remember, we changed our equation, so it is an 8 right here. And we do know the 5 stays. Doesn't match the right-hand side. -3 plus 8 does give you 5. And then again, it does actually land on this graph of the red line here. So that's the second way we can tell that it works. So an intersection point can also be called the solution of the equation, and you're going to see that more. So the ordered pair is a solution. Try and write this with my hard writing on a computer screen. All right, so an ordered pair is a solution to the equation. All right, it satisfies the equation if the point lies on the graphed line. Alrighty. We can also test a point to see if the solution if it is a solution by plugging in so we plug in the x and the y values from the ordered pair. This is what we did on that first example. We're going to see if it makes the equation true, meaning that the left side equals the right side. In that first example, remember we had 5 equals 5, so we knew that that point made that solution kind of true and showed it. Okay. The system of equations is a set of more than one equation. I told you this at the beginning, with the same variables. All right, and it has the same variables. The point of intersection of the two graphed equations is the ordered pair that satisfies both equations. So what this means is what we found 3, 5 on the last one, that is called the solution to the system of equations. And that's a bad T, but you get that it says solutions. Okay? Go to the next one. If you need to, pause and write them in if you haven't done that already. All right, number 5 says, what 2 equations are these on the right that is graphed? So we need to take a look. Let me get a different color. I'm going to look at this one first, this bottom line first, because I notice it goes through 0, 0. All right. And then let's look at the next good intersecting point. So maybe it's 3, 2. Another good intersecting point right here is 6, 4. And the last one up here, 9, 6. All right. So let's take a look. How do we find slope? If we remember, we're going to go how many up and how many over. The rise over the run. Rise and run. So we rise 2 and we run 3. We are going to write y equals 2 over 3 x. And that's it. We don't have to put the plus 0. The next equation is going to be my blue. So I'm going to start at the 2. That is my y-intercept. I can immediately come over here. I'll leave that spot blank, but there will be a plus 2 at the end of our equation. And again, I need to find good intersecting points. And what I mean by that is they go through these gray lines really nice right in the middle of that intersection. So I'm going to choose this point. Again, I could choose 6, 4 because we know that's our solution. And I can choose this point over here. Okay. I'm going to use these 2 coordinates and make my right triangle. I could use any 2 coordinates. So the rise is going to be 1 and the run is 3. So 1 over 3x is your part that we're missing in our equation. So that we have our 2 equations. Now number 6 wants to know, what is that actual solution? Okay, remember that solution is this intersecting point right here. We want 6, 4. Ooh, let me pull that down a little so it looks like a 4. Show work to justify our answer. Well, we can see just from looking at it that that point is on both of those graph lines. If we wanted to show an example, we could take 2/3, multiply it with our x value of 6, and does it equal 4, that y value that we're plugging in? 6 times 2 is 12. 12 divided by 3 gives you 4. We could show it also for the second equation, but it will work. Let's go to the next example. On these graphs, it wants us to graph these equations, find that intersection point, find the solution. Okay, that's that intersection point. And then we can check if you want to check. So I'm going to graph these. Y equals 5. The first thing I'm going to do is y equals 5. That is a horizontal line at 5. So I'm going to put my arrows on here for you. And then this one starts at the 3. So I'll put a dot. It is a negative sloping graph. So it's going to go down 1 and over 2 to the right. Now you might be asking, how do I know if it goes right or left? The down part, was our negative, and now the right is a positive action. So that means I am actually getting this negative sloping line that I really want. So I have to go up 1 and 2 to the left, and I just found my intersecting point right over here. So I'm going to draw a line connecting these. Sorry, I did not do it in 2 different colors, but hopefully you can tell the difference. All right, so our intersecting point. We're going to read -4, 5. We knew it had to intersect somewhere at 5 because there was no slope there. Use a different color. There we have a y-intercept at -2, so I'm going to start at -2. My slope is 1/3, so that means I'm going to rise 1 and run 3. Rise up 1, 1, 2, 3. Okay, I'm going to come down here. Down 1 and over 3. Those are the only points that I can make, because I just ran out of room on my graph. This second one starts at the 2, and it is a negative sloping graph. Remember, there is a 1 right here, so it is down 1 and 1 to the right for a negative sloping graph of 1. There's our intersecting point, and we'll keep going down 1 over 1. If we wanted to, we don't have to because we already know where our intersection is, but we're going to go up. Ooh, that is definitely not a straight line. Make yours straighter than mine. It's harder on the computer. So you know our intersecting point by now. It is 3, 1. Put it in parentheses. Let me show you in black. This was our intersecting point. This is our intersecting point. Remember, those are called solutions. So try number 9 if you have it printed out. If not, take a look at what I'm going to do here. So you can pause it if you want to. I'm going to start at the -4. This graph is definitely a little bit tinier. And I'm going to go up 3. 1, 2, 3, and over 1. I have to remember to go over 1 because remember it's rise over run. So 1, 2, 3, and over 1. And I'm going to continue. All right, so there's our line graphed. Then our next equation is -2x plus 6. So I'm going to start at the +6 up here at the 6, and I'm going to go down 2 and 1 to the right because it is a negative sloping line. I do see my intersection point, and I could potentially stop graphing right now, so I'm going to do that to make your video shorter. And our intersecting point is 2, 2. That is a solution. Remember, keyword there, math word, you'll see a whole bunch, solution. All right. And the last one, a parking garage charges $3 per hour for parking. Parking garage B charges a fee of $2 plus $2 per hour for parking. So we have to write the equations. $3 per hour, y equals 3x. Parking garage B, you have a fixed fee of $2 plus $2 an hour. Get my eraser because I did not mean to mark that. So let's get 2x plus 2 because that 2 is a part of our fixed fee. We're going to graph each of these. So this one will be blue if you need to know that, and that one will be red. So 3x, it goes through 0, up 1, 2, 3, and over 1 from our point. So up 1, 2, 3, and over 1, 1, 2, 3, and over 1. I'm going to draw a line connecting them, and I'm going to switch to red so you can see this one. So I'm going to start at the 2, and it says that my slope is a 2. So I'm going to count up 1, 2, and over 1, 1, 2, and over 1, 1, 2. Alrighty. They do intersect. It is slim, but they do. And it's right here at 2, 6. That is our solution. So what does that mean? You have 2 hours. These are our hours. And this would be our money. How much total cost we pay. Alrighty. Real quick, before I let you go, I want to mention pretty simply on a Desmos, on the graphing calculator of Desmos, you can type in what was ours? Y equals 3x. And then if you come down here to the second one, you can type in y equals 2x plus 2. And it does show you both graphs. If you kind of click and drag on your graph, you could see where they intersect. If you click on that point, it does tell you the point, and you can hover over it. You can click on many other points, and it will tell you 0, 2, 2, 6. It tells you one down here. Okay. Desmos is helpful when graphing. That's another way you could check to see if you graphed them correctly if you don't have one of those yellow TI calculators. All right. If you have any questions on system of equations, please let me or Ms. Hill know.